All right, so the objective of this video is to help you with parts per million problems. A lot of this is just algebra, to be honest with you. So success would look like this. We'll do this problem in a minute. The solubility of AgCl is 8 milligrams per 100 grams of water. What is the concentration in ppm? So first off, parts per million. Oh wow, this is in a weird order. Parts per million. You can find the equation for that right there on your periodic table. And it's pretty simple. It is, I have it somewhere over here, sorry, that your parts per million, or ppm, is equal to your milligrams of solute over kilograms of solution. It's pretty simple algebra. It's just 3 variables, and I'll always give you 2. Now, a couple things that are a little bit tricky is sometimes it's not given to you in milligrams or kilograms, so you have to do a conversion. So we'll talk about that. Please remember there's 1,000 milligrams in 1 gram and 1,000 grams in kilograms. So let's go ahead and attack this problem real quick. So it's the one that we saw that was what success looks like. So I know ppm is equal to milligrams over kilograms. It says the solubility of AgCl is 8 milligrams per 100 grams of water. What is the concentration in ppm? So we have the milligrams. It tells me it's 8 milligrams, but it gives me 100 grams of water, and I need this in kilograms. So to move grams to kilograms, I move the decimal place 3 places, and it becomes 0.1 kilogram. All right, then I just divide. I do not multiply by 100. This is not a percentage. I just simply do this. So 8 divided by 0.1 is 80 parts per million. That would be the answer. Pretty simple, hopefully. Now, just on this conversion, whenever we go from grams to kilograms, the answer gets smaller. That's from grams to kilograms. If we have a question where we go grams to milligrams, the question or the number always gets bigger. So it can go both ways. All right. Pause this real quick and try this question. It's different. Okay. So looking at this problem, we have the same equation, but this time it gives me ppm and kilograms. So it's just algebra. So Flint, Michigan had 13.2 part per million. So I'll just substitute that in here. 13.2 ppm. And it's equal to the milligrams over kilograms. So it says how many milligrams of lead are in 1.3 kilograms of water. So I don't know the milligrams, so I call that X, and I'm going to put it over 1.3. So now, just algebra, this thing, we multiply both by 1.3 to get our answers. I haven't typed that out yet. Hold on. So 1.3 times 13.2, and I just hit enter, and I end up with 17.16 milligrams. So that's just algebra, 3 variables. I give you 2 of the 3. You just do math. Okay, let's look at the next one. Pause this, read through it, and see if you can figure it out. Okay, this one has 2 steps because it asks 2 questions, sort of. It says, is Manaway's water safe? So the first thing we have to do is figure out the ppm in Manaway. So it says the safe level of mercury in a body of water is 0.11 ppm. A 1,500 gram sample of water from Manaway reservoir contains 0.04 milligrams of mercury. Is Manaway's water safe? All right, so what we're trying to solve for is the parts per million, and we are given milligrams is 0.04. We are not given kilograms. We're given 1,500 grams, but hopefully you remember we move that over 3 places. Whoops, I'm blind. That's 3. So I end up with 1.5 kilograms. Okay, so I'm going to divide 0.04 by 1.5, and I end up with 0.027. Now, it was really 666 forever, but I just rounded. Okay, so this is made up numbers. I have no idea what the real numbers are in Manaway, so don't stress. This is what we have here. So the question, though, is really saying, is Manaway water safe? If it is above 0.04, the answer would be no, but since it's less, then the answer is yes. Now, there's all sorts of other things in Manaway water, like swimmer's itch, so swim at your own risk. And once again, it probably has way less mercury in it than this. This was just an example problem. All right, so go ahead and do the final problem that will be on the Ed puzzle, and hopefully you feel okay about this.